Hello and welcome to another video for Olevel Maths. The chapter or the topic that I have for you today is called variation. Let's talk about variation. Variation relates to or more variables which are in direct or inverse proportion in an algebraic way. Okay, so that's how variables change with relation to one another. You've probably heard of direct relations and indirect relations and so on, and that's what this topic is about. Okay, so proportion describes the relationship of one thing to another in terms of quantity, size, or number. These relationships can often be expressed using formulae. So that's what we're going to do. We are going to turn inverse or direct relationships into equations and then try to solve them. The two main types of proportion that we will consider here, direct or inverse. A direct proportion occurs when quantities move in the same direction. Okay, so that if one quantity increases, the other one also increases. If one decreases, then the other one also decreases. Okay, a common example is the cost of goods. If $6 can buy 4 cakes, then $15 can buy more cakes, for example. Okay, how many more? That's for the direct proportion to determine. Okay, so inverse proportion, on the other hand, is the opposite of that. So if one quantity increases, the other one decreases, and if one quantity decreases, the other one increases. That's in this kind of proportional relationship, the product of the two quantities is constant. For example, the most common example of an inverse proportion is a speed and time relationship. So if you increase your speed, it's going to take you less time. If you decrease your speed, it's going to take you more time. Okay, so here's what you need to know. Most relationships in the world are direct relationships in terms of the variables that are concerned. So let me just fix this. So unless there's a specific relationship that says it's indirect, I'm going to list down indirects later on as well that you need to forward problems. But right now, what we'll have in the questions is that all of those relationships will be defined, whether they're direct or indirect, and you should be able to filter them out. Okay. Okay, so most relations are direct proportions. Okay, I can state that in a question in different ways. So, for example, this says direct proportion between x and y may be expressed in any of the following ways. Y is directly proportional to x, it means the same thing. Y is proportional to x, it means the same thing. You see the symbol, this indicates a direct proportion. Okay, so it's written like that. Okay, so it means the same thing. And I'm going to usually write it like that. Y varies as x. The ratio of y to x is constant. Okay. And that is probably the most important thing that I'm going to tell you. That whenever I say one of these things, it automatically translates to y equals to kx, where k is a constant that you need to find. Okay. Direct proportion may exist between y and as a function of x. If, for example, y is directly proportional to x plus 1 to the square of x plus 1, then y equals to k bracket x plus 1 whole square. So you can have relations that are not just simple linear quantities, they can be variations of x as well. So let's translate this. It is given that y is directly proportional to x plus 3. So what are you going to write? You're going to write k into x plus 3. Y is 5 and x is 7. Find the value of y when x equals to 3. Whenever you have such a situation, you first plug in the values and try to find k in this situation. So y is 5, x is 7. So k is basically 5 divided by 10, which is 1 over 2. And then you rewrite your equation with the value of k. Now what is the question asking you? Sorry, what is the question now asking you? It's asking you to find the value of y when x is 13. So it's usually a two-step question where you are supposed to come up with a final answer. In this case, the answer is 8. So y is 8 when x is 13. Let's see another example. It says y is directly proportional to the square of x. So what does this translate to? It becomes y equals to kx squared. That y is 25.6 when x is 8. Okay, I think I am going to need a calculator for this one. Okay, let's check. So the first thing had to be resolved. I had to find the value of k before I could do anything else. So that gives me 2 over 5. So I'm going to rewrite first. I'm going to say 2 over 5x squared. Now what am I asking you? Find the value of y when x is 3. Okay, since the previous one was a decimal, I'll put this in decimal as well. Okay, find the values of x. Values, more than one answer. When y is 40. So 40, 2 over 5x squared. 40 into 5 divided by 2. That's 20 into 500. When you put a root yourself, you're supposed to take both plus and minus values. So x can be 10 or minus 10. So x equals to root of 100, right? Plus minus. Okay. I can also put this in a word problem and it's going to work in the same way. I can say, for example, that the total cost t of a number of similar items n is directly proportional to the number of items. So t equals to kn. Given that the total cost for 30 items is 990. 990 for 30 items. So that will help me find the value of k. The k is 33. 99 divided by 3 is 33. Find an equation connecting t and n. So that's what I found. Even if the question isn't telling you that, that's what you have to find. It's the first step. What does the constant of variation represent in this example? Now it's asking me for an interpretation. Number of items is directly proportional. Okay, so that basically means that if this is t is the total cost, then 33 is the cost per item. Why? Because I'm multiplying it with the number of items. Okay, let's look at some other questions before we go on to inversely proportional. Okay, this says y is directly proportional to, when it says disproportional, it also means directly proportional. Okay, so you don't need to worry about that. The k is 4 over 9. Find an equation for x and y. So that's what I've already found. So 4 over 9 x squared. It is given that y is directly proportional to the square of x. And that y equals to 1 when x equals to half. Find a formula. Square of x. I missed the k. K is 4. So y equals to 4x squared. The values of y when x equals to 9. Values of x when y equals to 9. So 9 for part B. 9 equals to 4x squared. Again, I put a root. I should have both plus and minus. So plus and minus 3 over 2. Because this is the value for x. Okay. Y varies directly as the square root of x. So y equals to k root x. Into 3. I'm doing the same thing over and over in the questions. You see, most of these questions are worded like that, since some of these are actually past paper questions. So y equals to 6 root x. Given that y equals to 18 when x equals to 9, that's what I've already used. So 4 when x equals to 4. The root of 4 is just 2. 6 into 2 is 12. That should be my final answer that gets me 2 marks on the exam. Okay. The opposite of directly proportional then is inversely proportional. How do you then write the equation? It says in the same way. And you see this? That is what I will usually be writing out the equations as, whatever the relationship is given. Okay. So You can read through this. I'm going to make life easier for you. It is given that y is inversely proportional. So what I'm going to write, although the question is still not clear to me, is this. I know that this is going to be the case. It says an y is 3, x is 5. Find the value of y when x equals to 1.5. So the first thing that I will have to do is to find out the value of x. So k over 2. So k is basically 6. So I'm going to write y equals to 6 over x minus 3. And then I have to find out the value of y. That's 6 over 12, which is 1 over 2. Then for part B, what I will have to do is now I have to find the value of y. Okay, the easy way of doing this, okay, in any case, I'm going to cross multiply 1.5x minus 4.5 equals to 6. 1.5x, 6 plus 4.5, that's 10.5. What's 10.5 divided by 1.5? I remember this because I am good with tables. That's 7. If you don't, use a calculator. If you are still unsure, you will have to do some manual division and so on. If this is a no calculator question, okay? I don't know for now, so that's what I'm writing at. I would also see this in word problems. I'm just trying to see if my desired question is there. Yeah, okay. And it's there. Okay. I think that should be the end of this video. I will continue with word problems in the next video for you. Thank you for watching.